Right, so welcome to the last session of the day. I think we're standing between you and your evening party.
Yeah.
Right, so hopefully this will be interesting. My name is Rahul Krishna Gupta. You can call me Rahul. I work as a solution architect, part of the Global System Integrator Alliances team. So we work with the large global system integrators based out of India, the likes of Tata Consultancy, Wipro, Infosys, HCL, Cognizant, and Tech Mahindra. So those are the partners that I work with. And my colleague Manoj, he works as a solution architect on the team as well. And he has been on the other side in the past.
Yeah,
so part of one of the system
integrators. At the side of the table now.
So what we're going to talk about today is essentially based on the experiences we have had working on some of the autonomous driving development platform projects. And we are seeing a lot of those come into the market in the form of bids. We will take you through some of the market trends, the emerging landscape in the autonomous driving space. What are the typical requirements that we see that are relevant for us as SUSE, and how are we addressing those requirements by leveraging some of our products and capabilities? And then we'll look at the entire solution summary in terms of what SUSE stack fits into this space. So a lot of these developments in the transportation industry are driven by disruptive market trends, the changing consumer behavior, the increasing use of mobile apps, rising urbanization, rapid technological leaps, both in compute capacity as well as data center capacity, and the advent of cloud infrastructure. All of these are enablers for new business models in the transportation industry. What we are seeing is essentially the shared mobility and advanced connectivity services are leading to these new business models which are rapidly expanding. And if you just had to look at the scale of this industry, what is expected, the global autonomous driving industry is expected to be around $7 trillion by 2050. And a large share of that will be contributed by the shared mobility services, more than 50% of that, right? And if you look around, almost every automobile vendor and even some non-automobile vendors are in this space, rapidly competing to reach the level 5 of autonomous driving, planning to launch services on the road as early as 2020. And we'll see some of the vendors who are involved in these areas have already advanced a lot. We'll see some of the names in the next slide. So new technologies that are enabling this new industry, the advent of 5G, the ability to leverage artificial intelligence, the amount of compute capability that is available for that, vehicle-to-vehicle communication and vehicle-to-infrastructure communication, all these are enablers. And then what is also driving the race to more and more autonomous driving vehicles is also forcing the regulators to come up with new safety standards to take care of the advent of driverless cars. So if you look at the key leaders in the autonomous driving car space, and I don't expect you to read the slide, but you can see almost all the major automotive manufacturers are there. And the prominent one here, Waymo, they've already launched a commercial self-driving car service in December 2018, right? So driverless cars on a commercial basis are already on the roads. And some of these vendors are pretty close to putting driverless taxis on the roads. So it's happening all over. It's happening in Japan. It's happening in Europe. It's happening in North America. So a lot of these are starting out as development platforms, which means automotive vendors are running these driverless cars, capturing data, utilizing the data to run simulations and improve performance. So they're coming out with a lot of these RFPs and bids with the requirements. What I'm going to highlight here are the typical requirements that we see from these automotive manufacturers. And again, these are starting out on small scale, but even the small scale is a fairly large infrastructure requirement. So typically what we see is, one, there's huge amounts of data that is being collected from these cars, right? From the sensors, video images, all of those. So you need a huge data analytics platform and a data lake. That's one of the typical requirements that we see in a autonomous driving development platform requirement. Then you need a very strong, large-scale simulation platform that could be running on physical infrastructure. A lot of the customers are starting to run that as containers, containerized images. Because some of these new robot operating systems are available as container images, and customers are readily leveraging them. Then there is a need for a virtualized compute platform. Some of the workloads that can't run containerized would be running as virtual machines. And a software development platform. The need for developing newer applications rapidly is driving the need for a software development platform. And guess what? We're talking about huge amounts of data here. So you do need very large scale and highly scalable storage platform as well, right? And everything is being deployed on open source technologies, Linux. You will have a pretty large scale infrastructure requirement here. So you do need something that can provide you management services for the entire infrastructure, right? So how do we address all of these requirements? Where do the SUSE solutions fit into this entire story? So we are not at the application level here, but we are more on the infrastructure. So we are the infrastructure providers on which the entire autonomous driving development platform can be built. And whatever I'm going to talk about, we have actually been able to propose to a customer, successfully demonstrate to the customer. So these are all from our own learnings working on opportunities. Excuse me. So to address the requirements for big data or data lake, there is a need for certain parameters that the customer would look at. One is high availability, the ability to control the job scheduling and ensure that the jobs are continue to run. Scalability, performance tuning, security, data access at all times. You wouldn't want to enter into a disruption while a large-scale simulation is running and data is being read and written to this platform. And obviously, the entire support infrastructure around it. And then certain considerations that go into it. We are talking about clusters or Hadoop clusters of the scale of hundreds or thousands of nodes. That's a typical requirement that we see. Traditional workload assignment methods wouldn't work in this scenario. We need a distributed systems installation and management capability. Consistent node installation, you need to have a common profile across the entire cluster. And obviously, when you're talking about hundreds or thousands of nodes, you need a centralized patch management infrastructure for it. Multi-platform support can also be useful. The ability to run on different architectures across both on-prem and public clouds, that helps as well. So SUSE as a base operating system is perfectly suitable for this. Provides the base operating system for deploying any of the Hadoop distributions. Can be Apache Hadoop or can be one of the commercial distributions. It is optimized for massively data-intensive workloads. Basically, all the tooling that is required is already built in. And in addition to the base operating system, one very critical feature that can be taken care of is the high availability. In such a large Hadoop cluster, you wouldn't want your name node to be going down. So you can make the name nodes highly available using our HA cluster solution, right? and this is suitable for deployment across physical, virtual, or even mixed environments. So that's a very critical factor. And then additionally, in more critical scenarios, if the customer is also very security sensitive and you want to avoid unplanned downtimes due to some critical vulnerabilities that might come up, you can also add on the live kernel patching capability. So while a large simulation is running, if a critical vulnerability pops up and you want to patch your systems, you don't have to bother about rebooting them or shutting down the jobs and rebooting the systems. You can patch those systems using the live kernel patching capability. And then finally, in terms of the management, whether it is patch management or configuration management across the entire landscape, SUSE Manager can come in handy to provide the infrastructure management services. Again, it can manage both physical and virtualized landscapes. So the core infrastructure consisting of SUSE Linux Enterprise Server, the high availability extension, live patching, and SUSE Manager provides you that base. So that would address the need for a data lake or a big data cluster. The other very critical requirement in this piece is the simulation, because that's where all the data is being captured, simulations run on it, and improvements made to develop the platform further. What we are seeing is increasingly customers are going the container way in this area. Although most of the simulation platforms in the past used to be pretty much physical infrastructures because of the compute capability that the physical infrastructure provides, but a lot of the newer workloads are running containerized. HPC has been very extensively used in the automotive industry since a very long time. It has been found uses in the aerodynamic designs, engineering performance, tuning, fuel consumptions. But now we are also seeing it in the self-driving and autonomous driving vehicle space with the artificial intelligence and robotic operating systems coming into play. So HPC offers the right solution for a simulation infrastructure, but there are certain challenges. Challenges in terms of the complexity. There are so many different HPC tools that you get from so many variety of sources. How do you manage all of them? How do you deploy it in an easy manner? The maintenance part of it, maintaining the entire infrastructure, getting support on it, and time to solution. How quickly can you deploy and scale that infrastructure? All of those are addressed by our specialized offering for HPC. So we have a SUSE Linux Enterprise high performance computing solution that is based on SUSE Linux Enterprise Server, but more importantly, bundles a lot of these HPC applications, which you can take advantage of. So these are available right out of the box and fully supported. And in the projects that we worked on, we ended up using SLURM as the workload manager for running the simulation workloads. The other important aspect is that with SLES, we already have Docker containerization bundled, which means the container engine as well as the workload manager or the scheduler is all available right out of the box. So you can very quickly and easily deploy a simulation infrastructure for the customer. And this is highly scalable. We are looking at a simulation infrastructure that would span across hundreds or even thousands of nodes in such scenarios. The other thing is some HPC is a very vast area, and not all the packages might be bundled as part of the core operating system. So we do have a package repository called Package Hub. This is essentially where you will find a set of packages that are compatible with SLES, and you can very easily deploy them on top of SUSE Linux Enterprise Server without impacting your support SLAs. So if you have packages from Package Hub running on your SLES, our support team will still support you. Not on those packages, but your SLES deployments will still be supported. These are all contributed by community, some of them by our customers, and they are compatible right out of the box. And one of the interesting packages in the HPC space that you find here is Singularity. A lot of customers use Singularity for HPC applications running containerized. So this is one logical architecture from a POC that we did for a customer. And here you can see we're running a Docker engine on SLES, and we're using SLURM as the workload scheduler. And then Portus provides us the Docker registry from where we can pull the containerized images. So this is a proven architecture that we use successfully for a POC. The other interesting aspect in autonomous driving development platform is the use of GPUs. That's very, very critical. So we are working with NVIDIA very closely to have GPU support both for the physical infrastructure, it's already there, but also for the containerized infrastructure. So that is, you will see in all the autonomous driving platform requirements, a strong usage of the GPU infrastructures. So I'll now hand it over to Manoj, who will take you through the compute and the storage requirements.
Yeah, thanks, Rahul. So while Rahul has covered the requirement from the HPC and data lake, data analytics requirement that we saw in this opportunity, I'll be covering compute platform requirement that we saw, mass storage requirement that we saw in the opportunity, and the software development platform, right? So what requirement were there in this opportunity were the customer was looking for a flexible solution which can respond, quickly and easily to the new demands, because there is a huge data would be generated from the vehicles, right? And they would be running data analytics on top of that data. And it should provide agility. So in case of, there is a spike in the traffic, you can just spin up your instances very fast, right? Elasticity platform for increased innovation. You can just match it with the flexibility. Lower cost. So every customer wants a cost-efficient solution, right? And it should provide you faster return on investment. And how our GSI partner, made a decision to go for a private cloud solution, because there were a requirement to have a greater control and security on the solution. And while the rest of the requirements can be matched with the public cloud deployment, this greater control and security can't be matched there. So they went and choose for a private cloud solution, right? And the customer was looking for a self-service capability, a solution that can give them a self-service portal, right? So they can just go and spin up their compute platform over there, right? So there we go. We have a solution, private cloud solution, which gives you, which can match those requirements, which can fulfill those requirements that was there in the opportunity. SUSE OpenStack Cloud provides you all agility, flexibility, elasticity, and it can maximize the value of your existing IT. So as we all know, most of the organizations have already made the investment in their digital transformation journey, right? So OpenStack Cloud can utilize those investments and leverage those investments that have been made already in the data center space, right? It also provide bridging in between your traditional IT and agile IT that you have in current time, right? In traditional IT, you have monolithic applications running, and in agile IT, you have microservices-based architecture, right? Where you have containers running, and you can deploy both of them on SUSE OpenStack Cloud. It just gives you an abstraction layer where your application, can request for any resource requirement, right? And it can give you a compute storage and network all to the application, right? So as we all know, this is the analogy that we use to give the complexity of OpenStack if you deploy it with the upstream code. There are lots of services that we are aware that if you want to deploy a complete stack, you need to integrate all together. So if there is a requirement of a pre-built solution, that is where SUSE OpenStack comes into picture. We help you to reduce the complexity. We take out that complexity that our customer face while deploying OpenStack. So just in one of the requirement where it says it should be a cost-efficient solution, right? So there is an survey done by Forrester, the total economic impact on OpenStack Cloud. And what they have found in the customer environment where they have deployed SUSE OpenStack Cloud, the customer got return on investment 380%. And their payback was, it's less than 6 months, right? And they have reduced to manage and deploy OpenStack Cloud. There is improved productivity of development teams. So they improved the productivity of development team by 2.5 full-time employees. And because of the improvement on the productivity from both operation team and development team, they saw a revenue boost in their IT, right? So that was a very fit solution according to the requirement that we had in those opportunity, right? Going ahead with the mass storage platform, as Rahul has mentioned, there is a huge data that is going to be generated from the vehicles in the autonomous driving projects. So there was a requirement for storage which can, scale unlimited. It has to be reliable and robust. That is a common requirement, you can say, from the most of the customer. Again, it should be a cost-effective because the scalability and the amount of data that would be there in these projects. It should be agile in the nature. Most of the solution now we see agility is the primary requirement. And it should support the multiple storage protocols. So it has to be unified in the nature and provides you all storage protocol that is there in the storage space. And it should be non-disruptive if you expand that storage solution. If you want to add any storage node into the existing running system, we should not take down the storage system and then add the system. A new storage node into that. So it should be a non-destructive expansion, right? So we do have a solution in SUSE that can match up all these requirements of the customer. Our SUSE Enterprise Storage, it's based on the Ceph storage, Ceph project. It can deliver a highly scalable, so there is no limit in the scalability. You can add any number of nodes that you need. So there is a highly scalable and resilient feature there with no single point of failure. And having said that, you need to design the storage solution keeping in mind that there is no single point of failure. So you need to take care of that. But it gives you that feature. It reduces the IT cost as you can use any commodity hardware and disk drives to store your data. And if you want to add more storage into it, you can just add a node into the storage cluster and you don't need to do anything else. It will do that automatically. It will optimize everything, the whole complete system by itself, right? In the right-hand side, you can see the features that it provides. and we can match up those features with the requirement that we had from the autonomous opportunity. So it gives you a unified storage system which can provide your object storage, block storage, file system. We do have NFS. You can have NFS. We use Ganesha upstream project for that. You can have SMB. We provide a gateway called Ceph if you want to have SMB storage. It's resilient, self-healing, based on software on x86, right? And it is cost effective. It gives you public cloud like pricing. I would say less than the public cloud what they offer in the storage space, right? If I talk about the nodes, type of nodes in the SUSE Ceph storage, SUSE Enterprise Storage, there are three kind of nodes. The management node that helps you to deploy your complete storage cluster. Storage nodes are your actual nodes that are going to store your data. So we call it OSD nodes. And the monitoring node would be the nodes that would be monitoring your storage nodes. So if there is any failure, it will optimize your storage cluster, and you can replace your failed node into that, and then it will optimize your storage cluster again, right? Moving on, so this is the reference architecture for SUSE Enterprise Storage. As you can see, this is the complete cluster, storage cluster, where you have OSD nodes. These are the storage server where your actual data gets stored. We have monitoring nodes, which monitors these OSD nodes for any failure into that. And on top of this cluster, we have a RADOS common object store, which provides you all type of storage protocol that is there in the market, right? It provides you block storage with RBD and ISKZ, and you can access these block devices from any kind of client that you want. It's a heterogeneous environment you can access from. Now, in the new application, there is a requirement to have a S3 kind of object storage, so it provides you that as well. You can have a S3 or Swift object storage out of SUSE Enterprise storage, and it provides you file share as well with the Ceph FS, right? So it completely matched with the requirement that we had. Moving on to the software development platform, as Rahul already mentioned. Yeah.
Yeah. Well, just sorry.
Yeah.
How do you solve the problem of the analytics part, because you are missing the Hadoop connection on top of that? I mean, the analytics is normally carried on by Hadoop style of connection.
Right.
You have, in this way, you are covering the software in the loop, the hardware in the loop, but what is falling out from the picture is the analytics part. So you have a different block for storage, and you're moving data back and forth.
Yes, so it would depending upon the requirements. In this case, what we saw was the data analytics platform had a requirement for a certain amount of storage, and then a lot of the data after being processed was to be moved onto a archival platform, which would be this, right? But in some cases, if you want to use this storage as a backend for your Hadoop platform, there is a driver that allows you to use Ceph FS as the backend for your Hadoop infrastructure. So that integration is also possible.
And
so,
is it certified by Cloudera and all these guys? Funding guys that are
no, so we'll have to check. But yeah, so in this specific case, the requirement was not like that, so we didn't have to venture there. But yeah, that's a question that we would have to ask the the Hadoop distributions, how well they support. But that technical capability is already available.
Yeah. Okay, so software development platform requirement, as Rahul mentioned, that there are new application, cloud native application that these customers would be developing for the autonomous driving projects. So they wanted to have a platform which can, enhance their developer productivity, right? So as we all know, container is there for your cloud native applications, new application, and it accelerates your application development and delivery. You can build your new cloud application, native application on top of container, and it can modernize your legacy applications, right? So on top of the container, how we are going to enhance your application development life cycle. So we have a product based on the Cloud Foundry called SUSE CAP platform, right? And it's a one-step command that a developer needs to execute to containerize, deploy, and manage an application, right? He doesn't need to worry about the underlying infrastructure, its connection, its dependency. He just needs to worry about the application code that he's writing for the application. The rest of the things will be taken care by SUSE Cloud Application Platform, which is based on Cloud Foundry. It automatically identifies and pulls in all language libraries and dependencies via build packs, which is there in the Cloud Foundry. It provides you the service broker if you want to consume some services outside of Cloud Foundry. It gives you that facility with the help of service broker. So you can use service broker if you have any application or any service that is there outside of Cloud Foundry that you want to consume inside the Cloud Foundry application containers inside, right? As I mentioned, it automates application lifecycle management by assigning all the resources that is required for application to run. It manages routing, load balancing, and everything, scaling. So the developer doesn't need to worry about all these things. He just needs to write his code and just push it to the Cloud Foundry, and Cloud Foundry will do everything for him, right? So the Kubernetes provide you flexibility. You can scale your infrastructure with Kubernetes. Cloud Foundry provides you productivity, right? It's care about development team more. So it enhances, boosts your developer team productivity. SUSE Cloud Application Platform, as you can see, runs top of SUSE CAS platform. We have containerized it, and it is based on Kubernetes. That's why you see this box here where our SUSE CAS platform is running, and on top of this, we have SUSE Cloud Application Platform running, right? So this is the Cloud Foundry overview. As you can see, this provides you multi-tenant environment. It supports multi-languages. As you can see here, it supports most of applications that are there, web applications that are there in the market, be .NET Core, Go, HTML, Java, PHP, Ruby on Rails, Node.js. So it supports most of the enterprise applications, web applications that are there in the market. It has application autoscaler. So if there is a spike in the traffic, application developer doesn't need to worry about that. It's been taken care of by Cloud Foundry. It also have service broker that I mentioned earlier in the earlier slide that you can use to connect with the services that are there outside of the Cloud Foundry. It provides you user authentication. Then there is an API, Cloud Foundry API, that you can use to connect with the Cloud Foundry piece. Right? You can use Cloud Foundry command line, or we do provide a web user interface called Stratos if you want to connect to your Cloud Foundry. Right? And Stratos web interface also connects to the Kubernetes API, because your SUSE Cloud Application Platform is running on top of Kubernetes, which is provided by SUSECON platform. And you can also access these APIs using kubectl command line. And it is multi-cloud. You can deploy SUSE Cloud Application Platform on public cloud or on premises. So you can see here it supports all public clouds that are there in the market, most of them, AWS, Google Cloud, Alibaba, Azure. So you can deploy your SUSE Cloud Application Platform on the Kubernetes that are available on these public clouds, or you can deploy it on premises, and you can deploy it on the OpenStack as well, right? So how it accelerate your time to market, right? Earlier, what a developer used to do before Cloud Foundry, before SUSE Cloud Application Platform, if he wanted to deploy an application, he needs to request for a server. He needs to install the server, configure it, install OS on top of it, configure the OS, install middleware on operating system, configure middleware, install database, configure network, and then test that application on that platform, and then deploy it in the production environment. So you can see the complete loop he has to go. There are 11, 12 stages that he needs to perform before Cloud Foundry, right? With Cloud Foundry, he doesn't need to care about all those stages. He just need to run. He just need to develop his code and just need to run CF push. That's it. He needs to do. All these platform configuration will be done by Cloud Foundry, right? And if developer doesn't want to do it with the command line, he can do it with the graphical user interface as well. Right? So this is a picture showing where your developer is sitting and he's writing the code, and he's just pushing this code in the Cloud Foundry, and the rest of the things is taken care by Cloud Foundry. So that's how it's an powerful developer abstraction. It boosts your developer productivity. You have third-party service brokers, which you can use for connecting your third-party services that are there outside of Cloud Foundry, and it automates your application lifecycle management, right? So with that, over to you, Rahul.
Right, so just bringing it all together as to the individual solutions that we talked about, how does it look, right? So predominantly the products and the underlying open source technologies that are powering these products, that would form the complete stack, which we just highlighted. The important aspect here is we talked about specific set of requirements, reliability, scalability, robustness, support. All of those are addressed by our solutions, right? So we talked about the platform for Hadoop. We talked about the virtual compute platform, the high performance computing space, the CAS platform for our software development, the Cloud Foundry piece, and the big underlying storage infrastructure, right? So that essentially forms a stack that we have positioned in the autonomous driving development platform projects, and if you come across an opportunity, you can leverage these solutions. I think with that, I will conclude the session. If there are questions,
Yeah.
please. Yeah.
No question? Yeah.
Thank you.
Thank you.
Yes.